This is the start of Unit 3 for Honors Chem. In Unit 3, which is called Composition Stoichiometry, we will go over molar mass, which will be in this video, mole calculations, empirical and molecular formulas, and then 2 of the 3 main laws of chemistry, multiple and definite proportions. We'll go over the third law in Unit 4. The first thing I want to talk about is what the mole is. The mole is a counting unit, so it's a type of measurement, much like a dozen. A dozen is 12. The mole is 6.02 times 10 to the 23rd. We have such a large number because we're using it to count very small things like atoms, protons, molecules, stuff like that. So in order for it to be a meaningful amount, we have to have a lot of them. So we have 6.02 times 10 to the 23rd in our counting unit of the mole. However, it's just like a dozen. So you know if you have a dozen pencils, it's 12 pencils. If you have a mole of pencils, it's 6.02 times 10 to the 23rd pencils. If you have a dozen donuts, it's 12 donuts. If you have a mole of donuts, it's 6.02 times 10 to the 23rd donuts. Now, realistically, this number is very large. So having a mole of anything macroscopic that we can actually see isn't going to be useful. So here are some examples. 1 mole of seconds would be 19 quadrillion years. So it's obviously a very large number. 1 mole of sheets of paper, if you stack them one on top of each other, would reach from here to Pluto. So when we're talking about moles of atoms, we're talking about a lot of atoms. So that just gives you an idea of how small they actually are. Because we'll be measuring moles of stuff in lab, like we'll say a mole of this. And you can actually do that out and weigh it in the lab. So that brings us to molar mass. The molar mass, the definition, is the mass in grams of 1 mole of any substance. So that is what I was just referring to. We use the mole because in the lab, it makes the measurements more meaningful. If we have a mole of NaCl, we're going to find out what that mass is in just a minute, you can actually measure that mass out. If you want just 1 NaCl formula unit, that's going to be you can't do that in the lab. So using the mole means we can get actual meaningful numbers here in our lab. Now, one thing that students sometimes find confusing is that they think, oh, if the mole is always the same, then the molar mass always needs to be the same. But that's not true. The mole is the amount, meaning like the dozen is 12. The mole is 6.02 times 10 to the 23rd. If you have a dozen eggs, it's 595 grams, but if you have a dozen apples, which are much heavier, it's 1,000 grams. Okay, so you know that even though you have 12 eggs and 12 apples, they don't weigh the same. If you have a dozen pencils and a dozen Chromebooks, they're not going to weigh the same, but they are going to be the same amount. So that's what we're figuring out here. They will have the same amount of atoms, molecules, whatever in that if it's a mole, but they will not have the same mass. To find the molar mass, you use the atomic mass on the periodic table. This is the decimal number. We talked a little bit about it in the last unit, but I said it wouldn't be really important in Unit 2 just so that you could pick it off of the periodic table. So please make sure you have your periodic table and you look for the decimal number to find the molar mass, okay? The molar mass is in grams per mole. Atomic mass is technically in AMU, atomic mass units. It's the same number though. There's no kind of conversion. So what we'll look for is molar mass of carbon. So we take out our periodic table. We find carbon. And the decimal number of carbon is 12.01. So 12.01 grams of carbon is 1 mole of carbon atoms. So here the molar mass of carbon is 12, and you can put 0.1 if you want, but you can also round atomic masses. Grams per mole. And that's it. So if you're doing an element, it's really easy. You just look it up on the periodic table. What comes into play here is when we're doing compounds. So let's do some examples. The first one here, what's the molar mass of NaCl? So the way you do this is you look up the atomic mass on the periodic table, and you multiply that by the subscript for each element. So we're going to look up Na. Na atomic mass is 23. I'm just going to round that. So I'm going to write 23. And then I'm going to multiply it by the subscript. And because there's no subscript, you know that it's a 1. So this right here comes from the periodic table. And this right here is the subscript. And then you're going to add that to Cl. So we look up Cl on our periodic table. Cl is 35.45. I'm just going to say 35. And our subscript, again, is 1. So then you do that math out, and you get 58 grams per mole. So now I'm going to do the same thing for H3PO4. So I'm not going to go back to the periodic table. You should have yours in front of you. The atomic mass of hydrogen is 1. The subscript is 3. We're going to add that to phosphorus, which atomic mass is 31. We have 1 phosphorus because there's no subscript here. And then oxygen, we have 4 of them. So again, these numbers outside the parentheses are from the periodic table, and these numbers are the subscript. And when you do that math out, you get 98 grams per mole. So now we do BeNO3 too. Now you should be familiar with what this looks like because it is a polyatomic, okay, nitrate, and it has a 2 on the outside. The way that 2 works is that you distribute it. So it's kind of like if you had something like this. And I asked you to distribute that 2 in algebra class. You would leave the 2x alone, right? That 2 doesn't affect it because the 2x is outside the parentheses. And then this 2 would get distributed to both the 3y and the z. So you would have 6y and 2z. Okay, so all I did was distribute that 2 in the parentheses. We're going to do the same thing here. The only difference is that because it's a subscript, that's what you're going to be multiplying by. So this 2 is going to be distributed to both of the subscripts inside the parentheses. The BE that's outside the parentheses, you don't have to do. Okay, if it's outside, the 2 doesn't apply to it. So if you want, especially as you're getting to know this whole thing, you can rewrite this formula like this. That might be helpful for you. After a while, you won't need to do that, but it might be helpful as you're getting started so that you remember we actually have 2 nitrogens and 6 oxygens here. So once you do that, you're going to do the same thing. So beryllium's atomic mass is 9, and we have 1 of them. Nitrogen is 14, and we have 2. And then oxygen is 16, and we have 6. So now I'd like you to practice. Okay, so go ahead and you can pause this video, do these problems out, and then come back and I'll be writing the answers for you. This 2 minus here, that's that charge, that has to do with electrons. And you remember from unit 2, excuse me, electrons don't factor into mass. We say they have a negligible mass, so we don't care about their mass. When we were finding mass number, remember we added protons and neutrons and not electrons. So here you can also ignore this when you're finding molar mass. Okay, so just ignore this charge, just do the C and the O, 3. And then here for this one, you distribute that 2. The S isn't touched because it's outside the parentheses, so it's just going to be 2 nitrogens and 8 hydrogens. Okay, one more set of practice. For this one, you're going to translate these, write the formulas, and then find the molar mass of them. So go ahead and pause the video. You're going to write the formulas just like you did in Unit 2, and then come back and find the molar mass. I'll write the formulas first, so you can check to make sure you had those right. And if you didn't, go back and fix your molar mass before you come back. If you pause the video, fix your molar mass. So those are the formulas. Again, if you didn't get any of those right, just pause this, do out your molar mass over again. And then the answers for molar mass. And that's it for molar mass.